So thanks everybody for coming. The title of this talk is The New Gradle Model. And really, we're going to get into what this means and what is the old model and why is there a new one. But we're really talking about, at this stage, changing the way we describe what we're going to build. So effectively, how we build, the description of what we're going to build. That's totals all the way down, basically. So my name is Luke Daly. I'm a software engineer at Gradle Inc., formerly Gradleware. How that goes. Okay, so what's the current model? If we're talking about a new model, what's the one that we have now? And it's worth just formalizing this a little bit to understand what the difference is and why the difference is happening. Why the change is happening, I should say. So really, the current Gradle model is split into two distinct phases. Two things we have. We have a configuration phase and an execution phase. So when I ask Gradle to do something, these are the kind of high-level chunks of work that it goes through. So in the configuration phase, what's happening is we're taking all of the build logic that is defined. So you're not missing anything, there's just some bullets on the left-hand side, don't worry about it. So we're taking all the build logic that we can possibly find. Right? So these are things like my build scripts, my plugins, Gradle properties files, all the things that actually go into describing what happens. Then a bunch of stuff happens to basically process that logic. So we execute the build scripts, etc. And at the end of that, what we get is the build model, which is the description of everything that could possibly now happen with this build. So we take all the logic, put it through a big filter, a function effectively, and then we get a description of things we can do. The execution phase, which happens next, we take in that build model, and then we do some useful stuff. Right? This is where the things that you actually care about happen. We have the build model, which is this in-memory object soup. At the end of it, where the execution phase, we actually have the things. We have the jars, the artifacts, the things that we're actually trying to build. So the configuration roughly looks like this. It starts up, looks around, what's the build layout, where are my build scripts, how many projects do I have, etc. Then we go and execute all the build logic. Everything we find, just execute it basically like it's code, because it is. At the end of that, we know all the things. That's an important thing. We know everything that we could possibly now do with this build effectively. Execution, we interpret the user's request. We have the model of what could possibly happen. The user asked to run the build task. We inspect the model and say, okay, what does that actually mean? Well, it turns out to be these 5 tasks, queue them up, run them, ready to go. So currently, the model is at the end of configuration, we know all the things, and we build some of the things. This is really common. You just want to do a part of the actual build work. And so you can already see there's a bit of a disconnect in what's going on with what I would actually want to happen. Okay. And you'll often hear these terms thrown around in builds and people talking about Gradle, declarative and imperative. And we say Gradle embraces declarativeness as a tool. And what we really mean here is that the build model is declarative. So the description of what I want to happen kind of declares my intent. But really, the reality is that the logic that we write is completely imperative. Right? It's basically just sequentially executed code that at the end gives us this declarative model, but within that logic portion, it's very much imperative. However, through a bunch of different techniques and approaches, it's effectively declaratively styled imperative code. And we'll see what that means. So there's a bit of a disconnect there between, again, what the ideal intent is and what the situation is right now. So declarative, what do we mean? So this is kind of the canonical Gradle declarative example. Right? I'm saying there is a test fixture source set here. So this is a thing. I'm saying the test fixture in itself is not necessarily an executional unit. This build has some test fixtures, what it says. I'm declaring that's the case. And here is an example of what I would say is declaratively styled imperative code. Right? This is completely imperative code, but I can read it in a declarative manner. It very much declares the intent here that the compile class path for my test fixtures are effectively a superset of the test source set, compile class path. And we use this information, and why we say this is declarative is by declaring that there is such a thing as a test fixture, I get a bunch of machinery to do things with that. So Gradle says, okay, there's a test fixture. You're probably going to want to do something with that. So I model what I want, and something else takes care of the details of wiring up something that can compile it, the class paths, etc. But how does this actually work in practice? How do I make code like that actually do useful stuff? And the answer is a bunch of different tricks, basically. If you've ever tried to write a Gradle plugin that does this kind of thing, I'm sure you'll know what I'm talking about here. So a very common one and a very sort of pervasive technique that's used in a lot of Gradle builds are these domain object containers. Right? So in our previous example, we had this container of source sets. I could say there is a test fixture source set, there's a test source set, etc. And we can attach rules to these containers and say, well, whenever something pops up in that container, do this. Right? When I want to be able to wire in some compile stuff for that guy. Another way we'd achieve this kind of declaratively styled imperative code is using ad hoc lazy data structures. So things like file collection, which are very pervasive in the Gradle API, which represent 0 or more potential files, have inherent laziness built into them. If we go back to our example very quickly, the description here of compile class path plus equals test compile class path is a logical statement. And that works because the data structures backing this are effectively lazy. This is referring to some kind of container thing that is resolved later. And it's ad hoc because the design of that particular class and that code has to build in those mechanisms. This happens in a bunch of different places. But if you've ever tried to do this yourself with your own custom types, you'll know there's a bunch of kind of pitfalls there. Convention mapping. Who here has used convention mapping in a plugin? You're all naughty people. It's internal. Don't use it. I'm kidding. That would be a valid statement if there was an alternative. Well, there is an alternative. That's what this talk is about, I guess. So convention mapping is another approach here. And this is a more systematic approach to laziness, effectively. Being able to take any value and replace a literal expression of that value with a function, effectively. If you haven't used convention mappings before, if you go inside the Gradle plugins, the Java plugins, you'll see this all over the place. It allows me to say that this particular value in the model is this function, not this particular object, but this function. And just Gradle does some magic and it works. So that served us pretty well for a long time, and we've known that it has some sticky corners, and that's the reason it's still private, essentially, well, notionally private, and a bunch of other things, basically. So there are lots of other tricks, mechanisms, techniques you can use to get this nice, declaratively styled imperative code, but there's a bag of them. And it doesn't really work. Right? I saw lots of heads nodding before, people have run up against these problems. Right? So, and this is not quite a fair statement. It doesn't work as well as what we would like. So what are some of the problems? Well, these techniques, they're too eager. Right? It's making decisions about things before it's the right time to make that decision. It's too lazy, which is the flip side of the same problem, interestingly. So saying that, we'll get into what that means in a second. It's too magic, and I think this is probably one of the biggest ones, is that these techniques are hard for us to understand as Gradle implementers. They're hard for Gradle to understand as a tool. It's hard for all other kinds of things to understand about it. So it's not easy enough. So eagerness, what do we mean by this? If we go back to our example before, this is the kind of code that you would see implementing that ability to create some infrastructure based on a source set. So this is a very common idiomatic thing. So I'm saying to this source set container, attach this rule that whenever a source set appears, go ahead and create a compile task for it. That's what this is doing. Right? So as soon as that source set appears, just assume we're going to compile it, go and settle this stuff up. Right? The problem is there already, though, that we might not actually compile this guy. There may be no source, therefore why should there be a compile task? Right? So the decision here is too eager. It's happening far too soon. Feel free to ask questions during as well. I don't mind. We will stop for questions at the end, but if you want to ask during, that's also fine. So here's the same code, and here's an example of using laziness to try and get around the eagerness. So exactly the same thing, but now we're wiring in the class path of this particular guy. So we're setting the class path of the compile task to be the class path represented in the actual model, is what's happening here. And this works because that's a lazy data structure. compile class path is one of these file collections. It can change later, but it still works because when it's resolved, it gets that new information. So we have eagerness and laziness happening here. But the problem is that this might not change. The compile class path may have already been determined, so there's no point, next time I'm asked for it, recalculating it every time. Right? So it's the flip side of that. And that's a huge issue with performance, is that every time we're asked the question, hey, what is the class path of this compile task, we have to reevaluate that function because we don't know whether we can reuse the value from last time. So too lazy is probably not the right term here, which is not smart enough. I guess it's maybe better. Another really interesting one on the magic side of things, there's very little information that Gradle can meaningfully extract from this piece of code. The relationship between that task and the source set that it's derived from is effectively lost to us. As a human, I can understand it, hopefully, but Gradle can't do very much to say, well, if I want to ask Gradle, hey, why does that compile task have the configuration that it does? It can't tell you, well, because that source set has that configuration. It doesn't understand that relationship. So these things are kind of bound up in the data structures and these kind of ad hoc techniques. That really hurts us in a lot of ways. So there's really useful information there that we'd like to know, and we can't leverage it without a kind of formal way of describing this. Yes?
Just to give some more context, in that ... that you had on the way back slide there, you don't have to go back.
No.
Can we also assume that the new model is also going to deal with the after evaluates and the endless uses of with type all over the place?
Yeah, so the question was, in the list of techniques and tricks that we use to solve this, is one of those techniques things like after evaluate and the callbacks and that kind of thing? Absolutely, yes. Okay. Yeah, absolutely, yes, and we'll get to that. And really, this is the same thing. The .all is another example of exactly the same thing. Right, so just not enough comprehensibility in here for Gradle, and therefore Gradle can't help you comprehend what's going on. Diagnostics, when things go wrong, we can't really say why are they going wrong. Extensibility hurts there, and hinders optimization. This is a pervasive theme through the keynote and through Adam's talk, that performance is something that we're really focused on. And it's just too hard. It should be easier than this. There should be common standard ways of making this work that Gradle understands, that all Gradle developers understand, that Gradle users understand in terms of my casual build users making light customizations. It should be easier, and we can do better, and we are doing better. Another part of just wanting to do better than, say, today's Gradle and make it faster is actually we want to raise the bar on our domain modeling. So domain modeling is a big part of what Gradle does. I think Adam used probably the similar words in his talk. And it's really something that Gradle embraced in trying to open up the model compared to some previous tools that kind of locked you into a certain way of doing things. And Gradle tries to achieve this through domain modeling. And what we found as we tried to enrich the existing models that we had is these mechanisms for trying to translate the model into the execution layer, which is what we're seeing before. I had my model of my source sets was being translated into the execution layer as a task. That gets more and more difficult as the model gets richer. As the model gets more divorced from the execution model, which is what you want, it gets harder to translate it back in a well-structured way. So better domain modeling, what are some of the parts of better that we're interested in? Well, richer modeling. I want to model more things. Right now in the Java model, in the Java plugin, how do we model a jar? It's a task, right? So those two concepts are just completely smashed together, right? And that hurts us in a number of ways. And I'm using us, the collective us in this room. And if you think about it, just one good example of this is as a user of the build script, I'm kind of a light Gradle user. I want to make some customizations to how jars are being created. I go and look at the API documentation for jar, and I see everything from the task class there. All this stuff that I don't care about at all. I just want to say something about the jar manifest. I don't want to have to deal with all this other execution type stuff. So really what we want to do is model these things as what they actually are, and then translate them into the execution layer. And if you've used the new native stuff, the new Java stuff, the Android stuff was really the first widely used. Great example of this. It's a much more concrete model of what's actually going on that gets translated. Other side of that, cleaner modeling, kind of talked about that. Collaborative modeling, and this is really a big one. And this is something that we learned a lot from the Android plugin, is that many different people can say many different types of things about the model. This has to be built into it so that I can come along and say, I know how to do something to jars. I have some capability that if someone's building a jar and they want my capability, I can provide it. So not the jar task, but I can do things to jars, and then the user can select that and pull it in. That's kind of hard to make happen right now. So we really want, by having a rich, concrete model, the extension points kind of naturally fall out because people can say things about the concrete model. And also to be much more comprehensible. So in the situation where it's very collaborative and I have plug-in this, plug-in that, all doing different things, I want to be able to know who is actually doing what. Right? Why does that task have that particular value? Who contributed to that? Right? And that you'd have to do that in kind of ad hoc manner right now. So that's something that Gradle has to have much greater insight into how these things are hanging together. So that's effectively where we are. Those are some of the problems that we've identified with that. So what is the solution that we're proposing? What is this new model? So as Adam spoke about in his talk, the thing that we're targeting first is really the configuration phase. That's what we're going after, because that's where, for a lot of these things we pointed out, where the pain is. But we'll see that this isn't really about just redoing the configuration phase. Because really what we're doing is taking the same solution or the same fundamental approach to execution and applying it to configuration. So there's the unification there. And that's really a graph of dependent functions. That's what the execution phase is. We have a graph of functions, which are the tasks. They are dependent. We understand those relationships, and we just go ahead and do them. The task is fundamentally a function. It has some inputs, does some work, throws something at the other side. So it's taking that exact same concept and bringing it back. So as opposed to the configuration phase right now, it's rather linear. We just execute code at the end, hope for the best, basically. And importantly, an interpretable data model. And Gradle already has this at the execution layer today. Gradle can interpret the data in your tasks and do useful things. Incremental build is a very good example of that. Continuous build is another example. By being able to understand what those tasks actually represent and mean and get in there and extract that data, you can use that. Whereas at the configuration phase, we were talking about before, in the model, there's very little Gradle can actually understand about what's going on there. So really, this is a big unification of these concepts and marrying them together. Somewhat different clothing, though. So whereas we have tasks in the execution phase, we have rules in the configuration phase. It's very much the same thing. It's a function that does something to one thing, or said another way, it has some outputs, and it has 0 or more inputs as well. So very much like a task conceptually, but in slightly different clothing. And these functions are dependent because we understand the inputs are dependencies. So if we think back to our example before with the source sets, we actually had a dependency relationship going on there. We were creating a task based on a source set. So that task depended on that source set. The configuration of the task depended on the configuration of the source set. And as I said a number of times, that information was lost to us. We didn't understand that and couldn't actually order things correctly. What this gives us is a solution to the ordering problem, as you pointed out before. That right now, in order to actually order your configuration code correctly, you have to use a number of different techniques. There's things like after evaluate, there's a bunch of different ad hoc event listening mechanisms, etc. that you can use to do this. But by having a set of functions where there are formal inputs, Gradle understands those inputs and will satisfy them for you. Ordering just works the same way it does at the task layer. Yep.
Are rules going to be replacements for, or are they side by side? Are there use cases for tasks that rules will not?
So the question was, are rules a replacement for tasks? No. In the short term, no. There is still, while conceptually they do the same thing, there is still a practical need for there to be something called a task that I can think about doing some expensive, side-affecting work on the world, right? So that's really where the tangible, practical difference, whereas rules are building this kind of in-memory model of the way things work. For the most part, I'll come back to this in a little later, it's not always true, and that speaks to the unification aspect, but really safely, quickly building this in-memory model, but tasks are the things that do useful work for us. They're slow. We want to think about them a little bit differently. There tends to be far fewer tasks than there will be rules in a build, so we need to sort of visualize them differently, report on them differently, etc. But there are some interesting crossovers here, and I'll come back to that at the end as to what that is. So tasks aren't going away anytime soon, effectively, but we may find very soon that there are some alternative ways of specifying tasks or implementing tasks that are more closely aligned with this, but the capital T task as a thing isn't going away. So this is what a rule actually looks like. So we now have this thing called a rule source, and it is literally a source of rules and nothing else. So this is effectively the long-term replacement for org.gradle.api.plugin, right? So if you've written a plugin before, you'll know that the plugin interface does nothing. It's just an entry point for arbitrary code, right? This is the same concept. Instead of there being one entry point, you can specify multiple. So instead of having one big block of stuff that we just apply, you now have your logic broken up into small functions specified in a number of different ways that Gradle can actually understand. Right? So a few things, I'm going to go into some detail about this, but one thing I want you to keep in mind is that one thing we haven't really focused on as part of this work yet is making this very nice in terms of syntax, all that kind of stuff. There's a very deep, low-level layer to make all this stuff work, which is where the effort has been, and kind of popping out sugary bits on top as needed so far. So this syntax will get better. There will be more constructs for doing more common things. So just focus on the concepts, not necessarily the syntax right now, I guess is the point. So what is this doing? Okay, so we have class rules extends rule source. If you have a look at the rule source class, there are no methods, there's no fields, it does nothing. There's no behavior whatsoever. This is just to help out in some Java type signatures, etc. So there's nothing coming from rule source here. And, sorry, first question. So a stateless container of functions. It's not an object, right? You don't ever create one of these rule source things. It's just a way for you to contain functions. Java requires us to do this. So what do we have here? We have a method called add task, taking some things in. We have this annotation here saying that this is a mutation rule. This rule is actually going to mutate something, and by convention, the thing that it's going to mutate is the first argument to the rule. This is what we call the subject. Everything else, all the other parameters to this method are inputs. So here we have a rule that's going to create some tasks. This is the analog to the source set example before. Right? I'm going to create a task based on some other model element, which might be a source set. In this case, it's some contrived thing called my model. So when Gradle discovers this thing, when you say apply plugin and your plugin is now implemented as one of these things, Gradle will very quickly scrape out the information about this. So it now knows that there is this function, there is this rule out there that if I need to know everything I need to know about tasks, I have to execute. Right? It doesn't have to execute it straight away, it just has that information ready to go. This is what we sometimes call the meta model. Right? As I said, it's turtles all the way down. Right? So, and what we also know is that before we can actually execute this thing, we have to realize this guy. It's the term we use. We have to, all of the rules that say something about that thing have to have been executed. So just in the same way that you say task A depends on task B, and you ask Gradle to do task A, it will make sure B has happened beforehand. The same thing happens here. That if I need to know, if I need whatever this rule does, I have to have configured this thing first. So we end up with a graph of functions, and it all just works. And there's actually two rules here. So this is actually a rule that adds rules. And a rule is really just another kind of mutation. So this rule is working on the model map task, which is effectively a replacement for task container. Right? If you're coming along to the workshop this afternoon, run by Mark and Renee, I believe, is it you, Renee? Yeah. Model map, rule source, all this stuff, you'll get hands-on with it. Effectively, think of model map right now as a replacement for name domain object container from the API, that kind of thing. Has some key differences, and one of them is it allows me to specify new rules. So when I actually execute this guy, we're in a situation now where Gradle needs to know about all the tasks, which is every build where you ask a task to happen. We know we have to run this function. We can actually run this, and this method here on model map is creating another rule. So this new rule is saying, I create this actual task. So if you need a task with this name of this type, or speculatively something that looks like this, I have to go and run this inner rule. So even at this point, we're saving this work potentially if we don't need this task, because it's a separate piece, it's a separate function, a separate rule that we know only affects this particular task and nothing else. Therefore, if we don't need the task, there's no point running that rule. That's really part of the idea here. There are a bunch of different annotations I can specify that say different things. So if I want to, in the workshop this afternoon, we'll go through these, that I can say that I specify some kind of defaults for this particular model element. So let me run before any user code runs effectively. So I'm a plugin, I want to do that thing. I can say I have the last say on this thing. So let all the ad hoc code run on this, that is the user code. And then when that's done, give it back to me and I'm going to do some more stuff on it. And that is, if you've done any plugin development, a notoriously hard problem in Gradle to deal with. Right? I create something, give it to the build user, the configurer, and then give it back to me when it's done. And I'm going to do a little bit more with it. Right? And that's really easy with this new mechanism. Because I can say, I'm a rule, I work on this thing, and this is when I need to run in this kind of lifecycle state. This is the DSL version of the same thing. Question?
Is that how you're going to work around or get away from convention mapping or something? Because then you just password back and populate defaults.
So the question is this how we, is this a replacement for convention mapping?
The final state thing,
Yeah. So the answer is yes. There are no real tricks needed to do that anymore because we understand what the rules are, what they're effectively doing. It's a finalization rule, it's a mutation rule, it's a defaulting rule. Gradle can just order those things correctly rather than having to have that mechanism. And importantly, I'll dig into this a little bit more in a second, but not have to define this thing as a function. There's no lazy data structures going on here, no magic. These are all just plain Java objects, not even really plain Java objects, they're interfaces, as we'll get to. But there's very few mechanisms in play here, whereas in our previous example, we went through kind of 3 different mechanisms that are all kind of counteracting with each other. This is actually, when you get into it, quite a lot simpler, and there's fewer things going on. So this is what the similar kind of thing looks like at the DSL level. So here is a rule specified in my build script. Model is kind of the top level container that says there shall be rules in here effectively. We're saying the subject, like we didn't have a password or anything on that. The subject of this rule is the task container, right? So previously we had the type and we had tasks. Now we're saying, okay, the tasks is the thing I'm going to act on. Here is the implementation of my rule. It does stuff. And the same thing again here, we are using the create method of the tasks thing to be able to inject new rules. So really 2 rules here again. Syntax is a work in progress, and in the previous example we had this input coming in as an extra parameter to the method. Right now with Gradle 2.5, this is how you reference something else. Syntax is a bit funky, it's not going to be the final thing. As I said, sugar is not something we've really worked on yet. But what this is saying is that it's a way for us to understand at compile time, right? We don't have to run this code to discover that. We can work out without executing this code depends on this other thing. Yes, question?
You may be getting to this. Extensions, the role of what happens to extensions?
So the question is, what happens to extensions? What I'm not showing in these slides, but is covered in the workshop, is how you create things in the model space, which is basically replaces extension. So extensions, extra properties, all that kind of add stuff is replaced by this concept of model elements and the model graph. Effectively the same thing, formalized, fewer mechanisms. I'm coming up to that in more detail. Right, so again, the important thing here is that I have a function, a rule, that has formal inputs, declared inputs. In this case, we're saying I depend on the thing that is my model. When Gradle goes to execute this, it will make sure that everything that needs to be said about my model has been said. Right, so any functions where, any rules where that is the subject have executed first. We have in prototype stage at the moment some much better syntaxes for this that are much more natural, much more like what you would have in your Gradle build scripts today. This kind of dollars thing goes away. You can just reach out and grab things, and it works. Okay, so just a recap on why. I am skimming over a lot of detail on how this works and how you might use this in practice. The workshop this afternoon will cover that. Also, as we roll more of this out, we'll have good documentation on this stuff. But I really want to kind of make the case of why we're going through this change and what you're going to get out of it as this session. So ordering is a very big problem that we're solving via this. So by knowing what the rules are doing, Gradle can just make the ordering work, is the idea here. So I don't need ad hoc callback mechanisms. I don't need ad hoc lazy data structures. There's one way to specify what's going on, and Gradle does the hard work of organizing the graph and making things happen. At most once, laziness. And here, this is where, kind of alluded to this a few times, but by having this graph of functions, dependent, and if I know that that particular function operates on that thing, if for a particular build I don't need that thing, I don't need to run the function. Okay? But if I do need it, I can run it, but before I run it, satisfy all the dependencies. They aren't going to change. They're guaranteed not to change. So I only have to run that once. And I read the values, I derive whatever I need to do, set it, I never run that again. Whereas if we go back to file collection, which is an ad hoc lazy data structure, convention mappings, these things have to answer the question every time they're asked. So it's not at most once laziness, it's forever lazy, right? So we want things to be lazy until they're needed, and then from that point on, very cheap to read. And this is an interesting one, decouples logic from logic discovery. Right now, these two things aren't distinct in a Gradle build. For us to work out what the model is, we have to go out and execute a lot of logic before we can really answer basic questions. And that's expensive because it's arbitrary user code that we have no idea what it's doing, effectively. So in order to find out very basic things about the build, we have to execute code that we have no control over. Which means it's not cacheable, there's just nothing we can really do there. Well, nothing we can really do that's very satisfying. I mentioned previously that in this example, when I apply this plugin, this rule source, Gradle will immediately scrape out information from the method signatures here. And this is some logic discovery. We're now understanding certain things about this build, and more importantly, where I need to go if I need to find out more. And this can be very fast because we can write this code, we can optimize it, we can cache it, we can keep it in memory, etc. So we can do a lot of tricks here because we are in more control. And when we're talking about thousands and thousands of projects, that is critically important. Right? Before I can even answer the most basic questions, I need to have some information. In the case here, it's similar, because this rule, a certain part of it is interpreted at compile time. We use groovy sort of compiler magic to go and read this and work out, okay, that bit of code is going to depend on other things. So we're scraping out the same kind of information that we're scraping out of the Java method signatures. And what's a little bit implicit in what I've shown so far is that now these rules have identity. Right? That thing that added that task has a name, some kind of way we can refer to it. So we can track that and say that particular task was created by that rule. It's in the build script at this line. It's in the rule source with this method name, etc. So we can meaningfully answer questions like who contributed to this task. Say these are the things. It's very hard to do when you have just scripts with arbitrary code in them. Giving identity to different bits of code that do things is difficult. Whereas in this mechanism, these rules all have some kind of inherent identity. Performance. computing the model can be expensive, and by expensive, I mean anything more than a quarter of a second is too much, right? No one wants to wait that long before the build actually does what I consider to be useful work, like compiling my stuff, right? So expensive is a relative term depending on what you're doing, but we're really talking about getting this down to a quarter of a second type time. So we have to be very careful at what we do. And a couple of ways of doing this. Do I need everything based on what I'm going to be asked to do? Do I need to go and answer the question about everything that could possibly be answered? Well, no, we don't now, because we know what things say about other things. So we can just run those things. It's very important. Can we reuse anything? If we answered that question last time, can't we just take that same answer? That's really only possible if we know what the inputs are to that answer. Without knowing that, we've got no idea whether it's safe to reuse that. By having a formal model of functions with inputs and outputs, we can understand that. And what can we do in parallel? Similarly, if we don't know what the code's doing, we cannot parallelize it. But if we understand the dependencies between these different functions, we can easily, effortlessly parallelize it. There's no question there. But it turns out the rules aren't quite enough. Just having these functions doesn't actually get us all the way there. Gradle needs to be more involved in the data itself. So managed types, or managed model, refers to Gradle having and controlling all this data, and managed types are a kind of way of interacting with this. So the idea here is that you declare the structure of your model. Right? This is the data that I want, and these things become records, basically. Right? So this is my high-level model. This could be my jar, my native library, etc. is defined in terms of data. And I really am just declaring the structure here. And like how Gradle will go in and extract the information from the rules, Gradle will look at this, okay, now I understand this, generate an implementation at runtime so someone can use one of these things to do gets and sets, etc. Behind the scenes, this is all actually being stored in essentially a graph database. Right? We're extracting the data that we need from the actual objects. This has a bunch of benefits. One very interesting one is that while this is the description of the nature of the data, we can easily externalize that into some other form. So given this, we know how to read a properties file into this JSON file, whatever, web service. We can easily translate between these things because we understand the structure of the data. So why managed model? Also comprehension. Show me what the state of that thing is. If we understand the structure, we can come up with nice textual representations of it, etc. Enforced immutability, very important. If we're saying that for these rules, these functions, the inputs are realized, means that everything that can be said about them has been said. What's to stop somebody saying something they shouldn't, right? What's to stop somebody changing one of those inputs? Well, Java doesn't really give us much language support for this kind of thing, so we have to implement it in the objects themselves. And nobody wants to write that kind of code in their types. So by declaring your types like this, just a structure, Gradle provides the implementation. Gradle will enforce immutability at the right time. So you cannot change something you're not supposed to change, is the idea here. Yeah, question?
This might be silly, but it's kind of inverted where if I'm writing that interface, I have to know Gradle objects that I can use in that interface. I'm basically collecting the interface of things that are available.
So the question was, if I'm writing that interface, I have to know the set of things that are available to be used?
Like set string.
Right. So
was that what you meant?
So
like set name.
Yeah.
That's a declared defined implementation in Gradle. Because you said you're providing the implementation?
Yes, but not the structure. So you could call these fields whatever you like, whatever types, etc. We understand that something, okay, so yes, so what your question is now. We follow certain conventions. Something called set thing is a mutator, right? We understand what that means. So you try and call that at the wrong time, no good. Yes. So there are some well-tread paths here with these conventions and Java beans, etc. Okay, comprehension, show me X. Enforced immutability, very important. Consistency. If Gradle can generate the implementations for everything, we can enforce the same kind of patterns. I declare this thing as a list of string. Give me all the DSL sugary syntax that I want to be able to use to add something to the list, all that kind of stuff that at the moment you have to do in an ad hoc way. Gradle does some of this stuff for you some of the time, but by Gradle owning all of this, it can be really consistent. And that's a huge, huge win for users, casual Gradle users who just want to know how to configure something. If everything works the same way, I can look at the interface and I'm guaranteed that that's going to work a certain way because that's the way these things work in Gradle. That's a huge win. This is things like convention mapping and extensions and the other mechanisms. One of the reasons that they're still internal mechanisms and not applied universally is that unless Gradle is involved in creating all of these objects and implementation, it's hard to get that stuff in here. But with this approach, we're able to do that. And externalization is important for a number of reasons. Let me define my data in whatever format I like. I want my build users to be able to describe their dependencies in a YAML file, a JSON file, and have Gradle just translate that into the model that myself as the build engineer define in my Java models and that kind of thing. So that works both ways. I want to suck stuff in. I want to push stuff out. I want to visualize my build model on Gradle.com. Right, that kind of thing. Also externalizing it to, say, an in-memory cache so I can reuse it next time. And really to make that stuff work safely, universally, Gradle has to be in there. Okay, so so there is much more detail in the workshop this afternoon. There is some more documentation in the user guide going into detail on this stuff. So where are we at today? This is under very active development. It's something a lot of us are working on day to day. It is in use. The native plugin uses this stuff. The Play support is built on all this stuff. There is experimental JVM support available in master now. We don't publicize it very much, but it is there. You can use it. We are working closely with Zav and Zav's team to build the next generation of Android tooling based on this stuff. We're very committed to it. What I just said. And we really, a very strong goal for us is to get a complete replacement set of tooling out for the Java domain based on this. And also going further, the Java 9 support will be based on this, etc. So later this year, that's something we're looking to do. Okay, so what are some things that are in the near-term pipeline? Much better syntactic sugar. Make the stuff just look a bit nicer and read a bit nicer. That's what we expect from Gradle, both on the plugin level and DSL level. So one thing I just want to make clear is that in the examples we saw, they were ways to express rules. There are many possible ways we can express a rule. It's just a piece of code that we understand the inputs and outputs to. So there may ultimately be a few different ways of expressing that are more tailored to what you need at a particular time. Much richer managed types, so support for more constructs, different collection types, a bunch of things that you need to just model the domains that you need to model. Parity with existing constructs. So some things are just badly missing, like the ability to do things like all projects and inject across project boundaries and these kinds of things. So relatively small in terms of implementation, just things that we haven't quite gotten around to yet. So it doesn't have full parity with existing configuration constructs. A new way to implement tasks. The way we implement tasks right now is particularly problematic for parallelization, reuse, all these kind of things. So what we want to do is provide a new way for you to specify an task implementation that does stuff, and we will adapt it across and do all that kind of stuff, and it'll be parallel safe and all that kind of thing. So, legacy bridging. We already have legacy bridging. These two worlds, as Adam spoke about, coexist now. If you're running Gradle 2.4, some things are happening in this new world, some things are happening in the old world. We'll have a much more comprehensive story and a much more gradual story for bringing stuff across and having crosstalk between what we call the legacy world, which is we don't know much about what's going on, and the managed world effectively. So the story on migration and backwards compatibility is not fully written yet. Testing support. One of the nice things about this model is it's inherently more testable than the current model. You are forced to break up your stuff into small functions that you can easily inject mocks into and this kind of thing, rather than being forced to have big chunks of code. And it's very easy to provide a container that I can throw a bunch of plugins in, ask questions, and see what answers I get out. So test support is something we're working on as well, being able to really effectively test these rule source plugins, etc. And model reuse, Hans spoke about this and Adam did as well. It's something we're actively working on to keep my build model hot in memory in between Gradle runs. And that's really, for large builds, the only way we can get zero configuration time is to reuse the result from last time. That's something we're continuing to build out. It's there now. You can turn it on with a secret toggle. Your mileage may vary on how well it works for you, but it's something we're keeping working. And pervasive parallelism by default. This will just be the default way that Gradle works. So parallelize as much as it can. You don't have to think about it. By all our implementations of your model types will be fundamentally safe to parallelize. We just know what to do there. Again, that's a big story. So attend the workshop this afternoon if you'd like to get your hands on with this stuff. There's going to be some real examples of creating these types, creating rules, seeing the rules run, executing them, showing some of the comprehension support we have now for seeing what did what the model is, etc. And this is really, while we've been working this a long time, it's really the start of this story. So there's a lot to go, and we're really, really excited and confident about the direction and where we're going to end up with this. We'll end up with a much better Gradle, much more a fun Gradle to write for, and much more fun Gradle to use, and importantly, a much faster Gradle. So that's a question.
Yeah, in your examples of the tasks and all that, they were working, they were simple, but they were working with their inputs, right, which is sort of the whole contract. But does that mean that in the new model, some of the atomic bombs are going to, the globals are going to be frowned upon, or like project is like an atomic bomb? Right?
So the question was, let me know if I get this right, in the new model, are some of the global objects and global state going to go away?
Or be frowned upon you using them?
Yeah, that's the question? Yeah, absolutely. This can't work with that. And as Adam spoke about, this is one of the things that kills our optimizations, is having these global objects that are heavily mutable that can be changed at any particular time. It doesn't work with this approach, right? So there will be ways to get it. If I need to get a project on one of those things, I'll declare it as an input, and I'll get it. But you won't be able to reach out and grab something on the outside world. There's more to say here about things like external inputs, right? So if my actual data is some file on disk that I want to read, and that's an input to the model, we can actually do the right thing and treat that properly now and understand when that thing changes. I need to rebuild the model and that kind of thing as well. So
is it fair to say that the new model makes first-class use of injection as opposed to the casual use of injection?
Yeah, the question was, does the new model make first-class use of injection? Yeah, that's a very good way of putting it. Yeah, absolutely. What I didn't go into in any detail here is how Gradle, by specifying my model is an input, what the hell is that thing, right? So how does Gradle work out what it is? There's a system of binding to things in the model and specifying what I actually want. That if you've used something like Juice or Spring, you're very used to. Okay. Yeah, so yes, fundamentally. Jens.
One thing you talked about and one thing you have talked about a lot is speed.
Yeah.
But there's a corollary to speed, which is memory usage.
Yes, okay. Yep. So the question was corollary to memory, so speed usage, memory, so memory consumption. So is this stuff more memory efficient? The question. Absolutely, because we can page out state, right? So if we own the state, we understand these objects, we have the implementations. If that object is no longer needed, we can get rid of it. Or if we know it's actually going to be needed later, we could page it out to disk. When we need it, bring it back in later. So there's many, many things we can do here that we absolutely can't do today. And that's something we're very, very concerned about, is memory usage.
Do you have any benchmarks on those two dimensions?
So on the benchmarks that we have that Adam went into, the question was, do we have benchmarks for this kind of stuff? The new stuff is more memory efficient and faster. Basically, our implementations of this stuff are much better. All of the existing declaration we do is very heavy memory usage. The new stuff is much better. It wins all round, basically. And we can do even better.
So do you have memory benchmarks?
Yes, absolutely, yeah. Yep. Question in the back.
So will this new model make daemon more efficient?
The question was, will the new model make daemon more efficient? Absolutely, because we can do a much better job of caching and invalidation. So that's a big part of the daemon story, is keeping things hot in memory. And in order to do that, you have to know when to invalidate and understand the structure of the data. So we have to have this level of understanding of what's going on to be able to effectively cache. So,
Do you recommend using that CI2?
Eventually, yes. Our official recommendation now is not to use the daemon on CI, but as this becomes more and more, as we use it more and more, we will ramp that up and say yes. There are just some issues with staleness and whatnot along the processes, etc. But eventually, yes. Sorry, question.
So this model seems like it enables a lot of learning potential, especially with the Gradle.com initiative. I'm wondering if you can comment on some of the things that you're trying to learn about what people are doing with their tools.
So the question was, it looks like this can enable a lot of information and data about what's going on and how does that relate to Gradle.com and what are we trying to learn. Well, one of the things I would really like to know is who's using what, right? So what plugins is this build using, etc. You know, be able to correlate that. Also, to be able to understand preemptively spot problems. When a new release goes out, we can start to see that usage of this particular thing is slowing things down, etc. Know where to focus our development efforts. It's just there's no end to the good uses we can have of this information. So for us and also for yourselves as well. I mean, this is really taking about all that stuff that is invisible to you in your Gradle build. This is really letting you go and look through it and sift through it and understand why it's there. So you can imagine IDE visualization that lets me see my model and all the things that are there. Just answers the question, what is the compile class path of this thing? I don't have to write any code to do that. I've got a nice visual browser to do all that kind of stuff, right? That's a big advance from where we are today. Yes?
Does the existing plugins need to be rewritten to adapt to the new model?
The question is, do the existing plugins need to be rewritten to adapt to the new model? Yes. And how you go about that is part of our legacy bridging story. Do we want to have a smooth path where you don't have to take all of your plugins and one day convert them to the new one? You'll piecemeal move them across to get the benefits. Absolutely. Yeah, another question?
If there are new users to Gradle who are migrating from other build tools, do you recommend them to start with going directly to the new model or start with the old model? And how do you see that happening?
So the question is, if you have people coming new to Gradle today, should they bother learning the old stuff, basically, or just stick with this? They absolutely should learn the old stuff. Like this, the old stuff isn't going away in the next 2 years, right? There are going to be builds out there, and as much as it breaks my heart to say it, there are going to be legacy Gradle builds, right? So,
But don't spend time learning it.
so yeah, I think it's important to know, but it's certainly the ins and outs of intricate plugin development. I would say if you don't need to do that right now, just wait a couple months, we'll have a much better story, less hair pulling, kind of thing. So, but no, you can't ignore the last 4 or 5 years of history.
And
So,
when do you expect the bridge documentation to be usable?
by the end of the year.
Okay.
When do I expect the bridging documentation to be usable? By the end of the year, yes. Another question?
So the new samples that come down to the later distributions of Gradle
Uh-huh.
will have implementations of this new model that we can leverage and extend.
You can go on, yeah, so the coming, the question was, are the coming versions of Gradle going to have this stuff in it, basically, that you can go and extend and look at? Yeah?
In the samples folder,
Yep.
you have the existing
Yes.
samples.
So yes, 2.4 came out with some samples. Yeah, absolutely. So we will, as we develop more and more of this, increase the documentation. We're doing that as we go from this point on. Another question?
How would you qualify the quality of the samples of the new computer in 2.4?
So the question was, how would I qualify the quality of the samples of the configuration model in 2.4? There's 2 camps. One thing I haven't spoken about at all is the software model that Adam spoke about and what the relationship is here. We have some quite good samples of the software model. So I want to declare a new type of binary, a new type of transform from one language to another, aka compilation. That kind of thing. There are some good examples of that. I think we have some kind of markdown processor or something a little bit more sophisticated than that that you could use as the basis for implementing support for Scala or Kotlin or something like that. For the configuration model stuff, the samples aren't as extensive as what they will be in the workshop this afternoon, which you should all attend, by the way. So it will get better. So good, not great. Short answer. Probably should have started with that. Any other questions? So I'm sorry I didn't actually get you out early for lunch. Hopefully there's still some left. Thank you very much for your time.